Hello again. So hopefully you had a good time with the calculation of gravitational potential energy. I'm now going to do a short video to do the same thing, but instead of how to calculate kinetic energy. So, kinetic energy is the energy of motion. An object that has motion, whether it's vertical or horizontal motion, has kinetic energy. There are many forms of kinetic energy: vibrational, the energy due to vibrational motion; rotational, the energy due to rotational motion; and translational, the energy due to motion from one location to another. The amount of kinetic energy that an object has depends upon two variables: the mass of the object and the speed of the object. The following equation is used to represent the kinetic energy of an object. So the formula is the kinetic energy is equal to 1/2 mv squared. And kinetic energy is the energy due to the motion of an object. Now, EK, just like EP, is going to be measured in joules, J. It's going to have its mass measured in kilograms, kg. And it's going to have its speed, or what's known as velocity. It will have direction, but right now we're not going to worry about that. And the speed is measured in meters per second, just like the acceleration due to gravity with a gravitational constant was in meters per second squared. So it's important to have things in the right unit, and that is something that you always want to verify with your data of a given problem and convert to the right unit if necessary. All right, so if you were to derive these and manipulate them to be equal to other things, first of all, you can actually rewrite this equation, EK equals 1/2 mv squared, and you can actually write it as EK equals mv squared over 2. These two things are exactly the same. Okay. It's just a different way of looking at it. So you take your velocity squared, you multiply it by your mass, and then you either multiply all of that by 1/2 or 0.5, or you divide by 2. Mathematically, those are equivalent things. You can also solve for the mass. So if using algebra, you can solve for the mass, which is going to be 2 times the kinetic energy divided by the velocity squared. And you can also solve for the velocity. So the velocity is going to be 2 times your EK divided by your mass, and then you're going to square root all of it. All of it. Okay. So let's do an example of a straightforward calculation that you can try. Again, a really good habit to do is to underline the values as you read through and try to identify what kind of measurement they are, and then to write out a summary of the measurements and information you've been given so that you can just focus on what to do with the numbers. So a 60 kg student, that's your mass, is running at a uniform speed of 2.70 meters per second squared. That's your velocity. What is the kinetic energy of the student? That's your EK. So we know we're dealing with EK, but you can write out the things that you have. You have your mass, which is 60 kgs. You have your velocity, which is 2.7 meters per second. And it mentions kinetic energy, which it doesn't give you an answer for. It asks you what it is. So you have MV and are asked for EK. That should hopefully signal in your brain that, hey, I need this equation. Okay. So step 1, after reading the question, is to write down what you have. Step 2 is to figure out what equation or derivation of the equation you're going to use. And step 3 is to substitute, and step 4 is to solve. So we've just completed step 1, and we've actually completed step 2 because it's already in the right arrangement. We're solving for EK. EK is by itself on the left-hand side there. So we've finished step 2. Step 3 is to substitute values. Before you substitute values though, you do want to have a little mini step of just double checking to make sure your units are in the right units, and they are. So you can go straight to step 3 now, where you substitute your values. So instead of writing M, I'm going to write 60.0 kg. Okay, I can drop my units because I know that as long as my mass and velocity are in the correct units, that means my energy will be in joules. I don't have to worry about writing those things down. The velocity is 2.70 squared. Remember that because this is squared here, this needs to be squared here. And then it's all divided by 2. To go from here, we're going to follow bed mass. So I'm going to calculate what 2.70 squared is first. And I didn't actually write that down, so I'm just going to quickly get my calculator out. And I'm going to go 2.7, and I'm going to square it. So I have to do that square first because the E in bed mass exponents are done prior to multiplying and dividing. And 7.29 is the answer, and then divided by 2. Okay. Now, I know in bed mass, the D comes before the M, but you can actually interchange them. And here it makes more sense to multiply that by 60 first to get 437.4 over 2. So I've simplified the top. And then now all I have to do is divide that top number by the bottom number, and I'm going to get 218.7. And it's going to be 218.7 joules. There you go, and there's my answer. Try the rest of the practice questions. I hope it goes well for you. Thank you for joining me for this extension. Take care.